What a gorgeous day this is outside. And it's about to turn really ugly for somebody in a few minutes. Probably me. I'm trying to get somebody else to volunteer for it, but we'll see. Anyway, what we're going to focus on today is comparing theoretical probability to experimental or empirical probability. And what I have here, I'll show you what I have set up. Okay, I have here set up some eggs, some whipped cream, and a bowl of nearly ice cold water. There was ice in it, but it's melted now. But we'll fix that up. We have some more. And I have 4 blocks representing an egg. So there are 4 separate blocks here representing an egg. There's 3 separate blocks representing the cream pie. And there's 3 different blocks also representing the ice cold water or nearly ice cold water. What we're going to be doing is I'm going to be placing all 10 of those blocks into this box. And then I'm going to have some assistants draw from the box. And we're going to do 10 different draws from the box at random without looking. And we're either going to, each time we're going to draw either an egg, a cream pie, or a water block. And what's going to happen is somebody, probably me, is going to have one of those dumped or put on their head after the draw. Now, what's important is when we do this experiment, we will be putting or replacing each draw that we make back into the box so that we're always beginning the next draw with all 10 blocks in the box. All right, what we're going to be doing today is comparing theoretical probability to experimental probability. And if you see up here, I have TP, and that stands for theoretical probability. EP stands for empirical or experimental probability. Now, for the information that we have, I just showed you, there are 4 blocks that represent an egg that are in the box. There will be 3 blocks that represent water and 3 blocks that represent a cream pie in my face or on my head. So what is the theoretical probability then that an egg will be part of my punishment? Well, an egg will be drawn. The likelihood of an egg being drawn is going to be, since there are 4 blocks and there's a total of 10 blocks in the box, that's going to be 4 out of 10. So basically what that means is for every 10 times that someone draws in this box, probably 4 times an egg will be drawn. For water, since there's 3 blocks, and there's going to be 10 total blocks because each time we draw, we're going to put the block back in the box. It's going to be 3 out of 10, which means probably out of every 10 times that someone draws out of this box, that water will be chosen 3 times. And the same for the cream pie. Since there are 3 blocks and there are 10 total blocks, the probability is probably going to be about 3 times a cream pie is going to be drawn out of the 10 draws. It is time. So what I'm going to do is go ahead and place the 10 blocks into the box, and then I'm going to get my assistants to help me, and they're going to draw one at a time. And then each time they draw, they're going to place what they drew back in here, but we're going to record the results on the board. 3 waters, 3 cream pies, and 4 eggs. And we're going to shake this up and let my assistants take over. I'm just a little nervous.
There's egg. Draw 2. Egg.
That's gross. Oh my God.
Draw 3. Egg. There you go. Draw 4. It cracked in his head.
This is very uncomfortable.
Draw 5. Cream pie. Cream pie.
Whoa.
Wait, what draw is this? Draw 6. Water. Give me a minute. Draw 7. Egg.
Oh, well, that one didn't even hardly hit me. Oh well.
Draw 8. Water.
This is gonna be cold.
This is fun.
How many waters?
2.
Ah!
Draw 9. Cream pie. Draw 10. Egg.
The eggs are the worst. Oh, it fell off. It rolled off the back again. Okay, so what I've done now, I want to just focus on one particular element at a time here. So I chose the egg. Now, our theoretical probability to begin with was there were 4 blocks with an egg on it out of the 10 blocks. That was our theoretical probability of drawing an egg, or drawing a cube with an egg on it. And in our actual experiment, the results we obtained were it was drawn 6 times out of 10, which is it was drawn 2 more times than we expected it to be. Now, we can also break these things down. So our 4/10 would break down to 2/5. And then our 6/10 would break down to 3/5. So as a fraction, that's how we would represent it for the probability. And we can also say that our theoretical probability, we expect it to have an egg drawn 40% of the time, when in actuality, it was drawn 60% of the time. Now, for the water and the cream pie both, our theoretical probability, or what we expected it to be, was around 30% of the time we would have gotten that. However, it was drawn 20% of the time, which is a little less than we expected it to be. And again, it doesn't necessarily, just because the theoretical probability says that this is what you expect to happen, does not mean that it is always going to happen. But again, we're going to have to take a look at what's called the law of large numbers. We only did this experiment for 10 trials, 10 different draws. So in other words, if we were to conduct this same experiment, but we did, say, 1,000 trials, so we drew 1,000 times, putting each block back in every single time, probably all of our results would be much closer to what we expected it to be, the theoretical. There would not be such a wide gap, especially with the egg. The egg would, instead of 60%, would probably have been drawn closer to the 40% of the amount of times that we expected it to be. To recap, what we have here is the egg, which we expected theoretically to be drawn about 4 out of every 10 times, or 40% of the time. In actuality, in our little mini experiment, which it was only conducted 10 trials, or 10 times we drew. It happened 6 times, which is about 60% of the time, when we expected it to be about 40% of the time. So the amount of times an egg was drawn was 20% higher than we expected it to be theoretically. And then if you take a look here at the water and the cream pie, both of those we expected it to turn out to about 30% of the time, or 3 times each for being drawn out of the box. We ended up in our experiment, out of the 10 times, only getting it twice, each one of those twice. So they both came out to be 20% of the time, which was 10% lower than we actually expected it to be. We expected it to be closer to 30%, and it was lower than that. So anyway, what this experiment is showing is basically that theoretical does not always match experimental. So what actually happens or occurs doesn't mean it's going to be what you expect it to be all the time. That's why it's called probability. It will probably happen, but may not necessarily happen that exact way. I'm going to leave you with this. It's not one of my own, but it's a good one. What does an evil hen lay? Deviled eggs.